Greetings, my name is Andy Carter and I'm a professional civil engineer out of the state of Texas. In this video we're going to take a forensic look at the tragic flooding that occurred at Camp Mystic in the Texas Hill Country the morning of July 4th, 2025. The limits of this study is the South Fork of the Guadalupe River watershed located approximately 65 miles northwest of San Antonio. This approximately 97 square mile watershed is located 12 miles west of Kerrville, Texas. Multi-sensor quantitative precipitation estimation provided by the National Weather Service provides rainfall depths hourly in 1 square kilometer pixels. These images show rainfall depth in inches for every hour between midnight and 7 a.m. on July 4th, 2025. Note all times are in local Central Daylight Time. At midnight, no rain had yet fallen. At 1 a.m., rainfall over 1 inch per hour began to fall at the headwaters of the subject watershed. 2 a.m. Rainfall rates as high as 3.2 inches per hour are experienced on the southeast portion of the watershed. 3 a.m. The entire watershed is receiving rain with a maximum intensity of 4 inches per hour. 4 a.m. Main River sees as much as 3.5 inches per hour. 5 a.m. Direct rainfall into the basin subsides. 6 a.m. No rainfall in the watershed was recorded. This graphic shows the total accumulated rainfall between midnight and 1 p.m. As much as 10.7 inches of rainfall was recorded during this 13-hour window. This line chart shows accumulated precipitation at one of the rainfall pixels with this basin. The slope of the line is the rainfall intensity. A steeper line equals more intense rainfall. This HEC graph, or bar chart of hourly precipitation, shows the temporal variance in rainfall at the same point. Data from this HEC graph was plotted on a rainfall intensity duration frequency curve published in NOAA's Atlas 14. For a 3-hour duration, the July 4th storm was an approximately 256-year storm. This means that the storm has a 0.4% probability of being equal or exceeded in any given year. Camp Mystic is on the banks of the South Fork of the Guadalupe River. At this point, the drainage area of the South Fork is 87 square miles. Historical rainfall was applied to the entire 97 square mile watershed using HEC-RAS 2D. At 1:30 a.m., the simulation shows a flood 3 feet higher than the normal pool of the camp's lake. Stream velocities are less than 2 feet per second. At 2:30 a.m., the dining hall is encroached. Floodwater depths have risen over 12 feet in an hour. Velocities in the main river are over 11 feet per second. Vehicular egress has become perilous. At 3:30 a.m., all of the camp, with the exception of Senior Hill, has become inundated. In the last hour, water has risen another 9 feet. At 4:30 a.m., the floodwaters reach maximum depth of about 25.5 feet above the normal pool of the camp's lake. Velocities in the dining hall are about 8 feet per second. At 5:30 a.m., relative to the peak, floodwaters have dropped 6.5 feet. At 6:30 a.m., floodwaters have dropped an additional 6 feet. From about 2 a.m. to the peak at about 4:30 a.m., flows in the South Fork of the Guadalupe adjacent to the camp went from 4,000 cubic feet per second to 107,000 cubic feet per second. At its peak, the flow in the river was greater than that of Niagara Falls, and enough water to fill an Olympic-sized swimming pool each second. This model has limitations. It assumes no debris was carried, though floodwaters likely transported trees and mud downstream. Such debris could have temporarily dammed the river, worsening the flood before eventually breaking loose and knocking down downstream vegetation. This concludes my analysis of the Camp Mystic flood on July 4th, 2025. It is based solely on federally provided terrain and rainfall data and is without field verification. I believe understanding these events helps improve future preparedness. If you have questions or want to discuss further, feel free to reach out. Be mindful and stay safe. I am Andy Carter, and I appreciate your time.